Here we have our final example of blending the two rules we've learned so far. For this problem we have 2e squared f cubed, quantity cubed, times 5e cubed f to the fourth, quantity squared, times 1/10 e to the fourth f to the fifth g to the third. Notice that on this third part there is no exponent there. So we're not going to change this. We're not going to use rule number 2, power to a power. We will, however, use that power to a power for the first two terms. And so I'm going to put my exponents in here, and I simply want to distribute that. And so this becomes 2 to the 1 times 3, which is 2 cubed. I know 2 cubed is 8. E to the 2 times 3 becomes e to the 6th. F to the 3 times 3, which is f to the 9th, times, now I'll start this one, 5 to the 1 times 2 is 5 squared. 5 squared I happen to know to be 25. E to the 3 times 2 would be e to the 6th. F to the 4 times 2 would be f to the 8th. And then I'm just going to drop the parentheses here and call this 1/10 e to the 4th, f to the 5th, g to the 3rd. I'll begin by looking at my coefficients. Since this is all multiplication, I can say 8 times 25. I think about that for a second. 8 quarters would be $2, so that's 200. And then 200 times 1/10 would allow me to drop one of those zeros. When I multiply these three numbers, I will get 20. I go to my e's. Because I have like bases here, I simply add those exponents for the e terms. So E6 would be E12. E12, E4 would be E16. I move to the f's. An F9 and F8 would be F17. F17 and F5 would be F23. And finally, I see that I never used this G variable. Because there's nowhere else for it to be combined with, I'm just going to bring it straight down and call it G3. Remember that when you list your monomials, it needs to be coefficient and then all the letters in alphabetical order. In this case, E, F, G. There is the third example for blending Rule 1 and Rule 2. Rule 1 is where you have the base exponent, and Rule 2 is the power to a power. Remember to distribute. Never multiply a base times a power. It's just the base multiplied by itself that many times.